Welcome to the fascinating world of physics, where we explore the fundamental principles that govern the universe. Today we will delve into the concept of vectors, understanding their definition, representation, and the various types of vectors. Before we dive into vectors, let's revisit some basic terms. Physical quantities are measurable attributes in physics. A physical quantity is something that can be measured, such as length, mass, velocity, temperature, area, volume, and density. On the other hand, non-physical quantities are those that cannot be measured, like affection, love, anger, hunger, and pain. Physical quantities can be classified into fundamental quantities and derived quantities. To understand vectors better, we need to distinguish between scalars and vectors. Scalars have only magnitude, while vectors have both magnitude and direction. Let's first understand the term magnitude. It is countable or measurable and expressed in terms of a number and specified unit, like 10 kgs or 8 Newton. For example, the distance between Cyber Towers and Kukatpally is 10 km. This is a scalar quantity, specified by magnitude and a unit. But what about direction? We haven't discussed it yet. Now let's consider displacement. The displacement between Cyber Towers and Kukatpally is 10 km north, which includes both magnitude and direction. A scalar quantity has only magnitude and no specific direction in space. Examples include length, volume, time, and mass. A vector quantity has both magnitude and direction in space. Examples include velocity, force, displacement, and torque. To summarize, scalar quantities have magnitude only, while vector quantities have both magnitude and direction. The displacement of a body from point A to point B is represented as a vector, symbolically written as shown. Now, let's explore the different types of vectors. Equal vectors have the same magnitude and direction regardless of their positions in space. Opposite or negative vectors have equal magnitude but opposite direction. A unit vector has unit magnitude in a given direction and is represented as A. Rectangular unit vectors are along the positive directions of a coordinate axis system. A position vector represents the position of a point in magnitude and direction with respect to a coordinate system. Thank you for joining us in this exploration of vectors in physics. We hope you found it informative and engaging.